Alright, so here is a gas stoichiometry type problem, and what we're given here is a reaction, and we're looking for the volume of CO2, but we are given the mass of propane gas here. So CO2 is here, but we're starting out with a certain mass of C3H8 gas. So what we're going to have to do is a little bit of stoichiometry first to get the number of moles of CO2. Now the reason I'm after moles is because eventually I'm going to have to use PV equals nRT, which means I'm going to have to find a number of moles of CO2 in order to make this work. Alright, so the little flowchart I've been using for stoichiometry is this one. And what we've got here is a mass of C3H8. That's going to be my quantity of A. Then I'm going to find moles of C3H8, and then I'm going to find moles of CO2. Alright, so let's see how that's going to work. 376 grams C3H8 times, now I know grams of C3H8 goes on the bottom because I need that to cancel, and moles of C3H8, that's going to go on top because that's what I want next. The relationship here will be 1 mole, and I'll let you figure up the molecular weight of propane. Alright, times and then a line. We'll have moles of C3H8 on the bottom here because we know that has to cancel, and what we're looking for now is moles of CO2. Relationship here, we go over the reaction, we can see that 3 moles of CO2 is equal to 1 mole of C3H8. Alright, and that's going to end up giving us a certain number of moles of CO2. Alright, so now we can go down here and we can use our PV equals nRT. The R value, 0.08206 liters atmospheres per mole per Kelvin. Also written as this, and these have negative ones because those are on the bottom. Pressure, 0.989 atmospheres. Alright, that unit matches the unit that we have in R, so we're good there, we don't have to change that. Volume, that's what we're looking for. N, that's going to come from over here, so that'll be moles of CO2. That'll go in here, and the temperature is going to end up being 588 kelvins. Alright, so in order to get the volume here, we know that PV equals nRT, so V will equal nRT over P. The N, that's the number of moles we get from up here. Times the R value, 0.08206 liters, atmospheres, moles, and kelvins, times the temperature, 588 K, over the pressure, 0.989 atmospheres. Alright, so you see that the atmospheres will cancel. The liters is what we're looking for. Moles will cancel, and kelvins will cancel, and we'll end up with a value that will be a certain number of liters. We'll end up having 3 significant figures.